y squared equals 5, y equals the square root of 5. Down here it would be the same. It would be the same triangle because we're also at negative 2. And it's going to be negative 2, and then this would be a negative root 5. So here we're at 2 comma root 5. Here we're at 2 comma negative root 5. And then what we can do is we can use this tangent theta to find this angle, right? And find the reference angle and go from there. So I'm just going to go tangent theta equals square root of 5 over 2. We can make it negative if we want. Doesn't really matter. But if you prefer, sorry, these should both be negative 2's. My bad. Right, because it would be positive here, it would be negative there. So I'm going to go on the calculator. So second, tangent inverse. Oh my goodness, it's a busted calculator. So square root of 5 divided by 2, parenthesis, hopefully you can see that, I don't know. I haven't used the calculator on the YouTube yet. And we get about 0.841. So this is about, sorry, the theta is tangent inverse of root 5 over 2. But it's not theta here. It's going to be 180 minus that, right? So we'll not call that theta yet. So this is 0.84 about, approximately. That's this angle. That's the reference angle, right? Need a different color. That's this angle right here. Right? That's our reference angle. To find theta, it's going to be pi minus 0.84. So pi minus 0.84 is about 2.3. 2.301, so about 2.3. So this angle is 2.30, so 0, 1, so it's 2.30. And then this, right, would be negative pi plus that. Or it's just the reflection of it in this case. So here we're going to say theta equals, this theta is negative 2.30. So our bounds, we've got our equation. Our bounds here are between negative 2.30 and 2.30. So that's the extra part that I'm asking for with this. Is here, if I limit what x's and y's I'm talking about, it's going to say, it's going to have to limit what theta, or maybe in some cases, the r value that are getting worked on. Okay. So now, just to talk a little bit more about it, if, let's say, instead of that, we had 0 less than or equal to y less than or equal to 3, if this were the case, instead of that, it would have just given us this part of the graph right here in pink. So here, theta would have gone from 0 to 2.3, about 2.3 there. Right? If y just went from 0 to 3, it would just be the top half. Because y covered that full negative 3 to 3, right, we got that Pac-Man shape. Okay, let's try the next problem. Oh, what am I doing here? Yeah, so go ahead and, try those examples. And then we're going to work through going the other direction, starting with polar equations, going into rectangular, and then same idea, but polar rectangular again. So you might want to pause it, track out problems, and come back. Okay, so going from polar equations to rectangular equations now. So here we're going polar to rectangular. So let's say we have the equation r equals 10. Let's say we have the equation theta equals pi over 6. And let's say we have the equation r equals 8 cosecant theta. So those are our 3 problems that we're going to do for examples, and then you've got some to work through. in your notes. Not in your notes, sorry, in your assignment, not notes. So here, r equals 10. Well, I mean, I don't really have like just an r equals up here to work with. So what I'm going to do is I'm just going to square both sides because it'll still be equal. So here, r squared equals 100. What this is saying is, hey, radius is 10. What kind of shape has a radius of 10? I mean, I can't actually hear you through YouTube, but yeah, you're right, a circle. So here we go r squared equals 100. R squared is x squared plus y squared. Done, that's it. Hooray! Okay, got that one. Let's look at this one. Well, tangent theta equals pi over 6. We don't just, oh my goodness, theta equals pi over 6. We don't have like a theta equals thing, but we do have, as I just said and ruined it, spoiler alert, we do have tangent theta. So we know tangent theta equals y over x. So tangent theta, if we just take tan of both sides, I get tangent of theta equals the tangent of pi over 6. Well, tan of pi over 6 is root 3 over 3. And what do I know that the tangent of theta is equal to? Yeah, y over x. So here we get y over x equals root 3 over 3. And we just multiply both sides by x to get a y equals equation, because that's what, like, how we want to write linear equations. It's nicer that way. So y equals square root of 3 over 3x, which we saw in the previous problem going from rectangular to polar, right? It goes both ways. All right, lastly, we have r equals 8 cosecant theta. Well, rats, we don't have like a cosecant up there, but we do have a sine theta, right? Like our sine theta is y. And we remember that cosecant theta is the same as 1 over sine theta. So this is the same as saying r equals 8 over sine theta, because cosecant theta is 1 over sine theta. I can multiply both sides by sine theta to get r sine theta equals 8. And, oh look, r sine theta is y. So here, y equals 8. Got it. Cool. That's it. Yeah, so with these, basically what you're trying to do is like make it squared so you have an r squared by squaring both sides of the equation. If you set a theta, take tangent of both sides. So you get a tangent theta, which you can then replace with a y over x. If you have a secant or a cosecant, turn it into a sine or a cosine, and then multiply it, or sorry, yeah, turn it into 1 over sine or 1 over cosine, right? You can't just go like secant equals 1 over cosine, and then multiply on the other side to get an r cosine or an r sine. Cool. All right, so we're going to get to the more interesting stuff now, I promise, which is similar to what we did on the last step, but we're going to throw in some bounds. So it's like this, but with some numbers in there, like r's between these or theta's between those. Okay. Then you gotta find the x's and the y's. Okay, so take a moment, you can try those few next problems, and we'll go, I'll put the next examples up. We're still using these. These are like, just like know those and how to manipulate them. You got this whole assignment. Mostly, kinda, I guess. It's really hard without like getting feedback when I'm talking. I hope this is making some sense. Okay. Well, let's try example 1. We've got r equals 5. And then here I'm making pi over 2 less than or equal to theta less than or equal to 7 pi over 6. And what we're going to do is we're going to say, well, what's the equation when r equals 5? And then what part of the circle do we have? So what are the bounds or the domain and range on x and y? All right, so here, r is equal to 5 just tells us, well, r squared equals 25, square both sides. So x squared plus y squared equals 25. Oh, that's not a 25. There we go. Boom, that's a circle with center 0, 0, radius of 5. Now we're going to do the interesting part. Now we're going to look at this circle with a radius of 5. And we're going to go from pi over 2 to 7 pi over 6. So here, we're taking this chunk of that circle. Just that outer part. We're saying, okay, what are the biggest, smallest x numbers? What are the largest and smallest y numbers in this chunk of the circle right there? So I look at my x numbers. It goes from some negative right here, right? This is kind of like my endpoint. Actually, what's the smallest x gets? Right here, it gets all the way up to -5, right? That's -5 comma 0. And here, this is 0 comma 5, right? So my x's, and then back here, the x's are getting closer to 0 again. So x is going to go from -5 to 0, right? We only get these x's here. If I squash this onto the x-axis, that's all I get. The y's are a little bit more interesting here. Here, I get the y's from this point, which you don't know yet, up to 5. So here, y is going to go up to 5, but it's going to be below 0. That's going to be like right there. And we know this angle is 7 pi over 6. So I can look at the reference angle, where I can say, hey, this is just like, what point is that? Well, it's 5 cosine 7 pi over 6 for my x, 5 sine 7 pi over 6. Right? X is our cosine theta, y is our sine theta. Right? So my y value, the smallest y value I'm going to get is this. And 5 times sine of 7 pi over 6 is 5 times -1/2, which is going to be -5 over 2. Or -2.5. And that's it. That's all I'm looking for there. The equation, the bounds on the x's, which might be a little tricky because it covers all from 0 to -5 there. And then the bounds on the y's, just find that lowest point and use the x equals r cosine theta, y equals r sine theta. And if you want to, you can use, right, a program on the internet to like plug in 5 cosine theta, that sort of thing. Or like use unit circle. You can look the unit circle up if you don't have a copy with you. All right. That's that problem. Now let's look at if theta equals 2 pi over 3, and here 0 is less than or equal to r is less than or equal to 8. Okay, cool. Well, we're going here, right? Theta equals 2 pi over 3. What we want to know what the equation is, and then what x's and y's do we cover. So here we're going to take the tangent of both sides. Tangent, tangent. So tangent theta equals tangent of 2 pi over 3. That's square root of 3. Oh, no, sorry. 2 pi over 3. Even I have to do this sometimes. Right, it's -√3. Right, it's going that way. Because we're on the left side of the x-axis. And then this means y over x equals -√3. Or we get the linear equation y equals -√3 times x. That's our equation. Now we got to find the bounds for the x's and the y's. So we're going to go less than or equal to x, less than or equal to, less than or equal to y, less than or equal to. And looking at the graph of this, I'm going to make this a little bigger. We've got, I'm going to make that dry now. We've got this 2 pi over 3 with positive r values. That's going to tell us all the way out to a radius of 8. So we've got everything from 0, 0 to whatever that point is right here. We're like, well, what's that point? Well, we know the radius is 8 and the angle is 2 pi over 3. So I can just say, well, what's the x number? The x number is going to be 8 cosine 2 pi over 3. And then the y number is going to be 8 sine 2 pi over 3. Right? Just using x and y from up there, knowing that this is my r and that's my theta. So this is the x is going to be negative here, so that's going to be my left bound. Now, cosine 2 pi over 3 is going to be -1/2. So 8 times -1/2 is going to give me -4. And the furthest to the right that my x goes is 0. And now my y, this is actually the tallest my y goes, and this is the smallest, the lowest that my y goes. So y is going to go from 0 all the way up to 8 sine 2 pi over 3. Sine of 2 pi over 3, this is going to be 8 times root 3 over 2. Root 8 divided by 2 is 4, so we get 4 square root of 3. And you can use a calculator to help you out with this, to double check and that sort of thing. Okay. All right, I'm going to try to squeeze one more in here. All right, here we have r equals negative 10. Oh, not cosine theta, cosecant theta. Sorry, cosecant. Cosecant theta. So remember, if you get a cosecant or a secant, right, rewrite it, because we're going for the equation right here. Oh my goodness, I didn't tell you what the bounds were. Sorry, I'm getting ahead of myself. Here we have, let's write it. Yeah, sorry. Let's write it here. The bounds are 3 pi over 4, less than or equal to theta, less than or equal to 5 pi over 4. Okay, so with this, what I'm doing is, hey, cosecant is 1 over sine, right? So here I have negative 10 sine theta is r. So I'm going to, sorry, totally wrong, divided by sine theta. Now I'm going to multiply both sides by sine theta. So I get r sine theta equals negative 10, and r sine theta is y, so here, y equals negative 10. Awesome, hey, we don't have to worry about the range. The range is just y equals negative 10. That's it. What we gotta worry about is, what are the x numbers? What's the domain? So x is gonna go between two numbers, and our job is to find out what those two numbers are. So here, I'm gonna draw a little graph, because graphs are helpful. We've got x and y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. And I've got an angle of 3 pi over 4. Uh-oh. Oh my goodness, I goofed. I'm going to change this. Sorry, on your assignment it actually works. I totally goofed. This is going to be 5 pi over 4. My bad. All the way to, to 7 pi over 4. Sorry, change that. 5 pi over 4 to 7 pi over 4. If I had this angle up here, this wouldn't work. Sorry, it wouldn't. That'd be positive. Okay. So here, we're going to go 5 pi over 4. And this is going to be the angle 7 pi over 4. So basically we get what looks like, and in fact is, an isosceles triangle. Right, because this reference angle is pi over 4, that reference angle is pi over 4. If these were not both over 4s, it would not be an isosceles triangle. It's not always going to be. It won't be on all the assignment problems. Okay, but let's just go ahead and figure out, well, what are these points? Well, I know the y value is 10, right, negative 10. I know this angle is 7 pi over 4, and I know tangent theta equals y over x, right, so that we can solve for x. Or you can kind of look at just the triangle, right, triangle trig, right, 10 pi over 4, look at the reference angle, right, opposite over adjacent tangent. So we're just going to solve this. Tangent theta equals negative 10 or 10, right? Go negative 10 over x. And theta is 7 pi over 4, using this one. So x equals negative 10 over tangent 7 pi over 4, right? Multiply by x, divide by the 7, or tangent 7 pi over 4. And we get negative 10 divided by tangent of 7 pi divided by 4, which you don't need to use a calculator for, because Well, I had to use a calculator, that was silly. Tangent tells us the slope, right? What's the slope there? 1. So this is going to be 10 as well. So this is 10. And then this is going to be all the way out to negative 10, comma 10. In general, you can just use this, or right here, you would just say 1 equals negative 10 over, in this case, it would be negative 10. Oh, sorry, it would be negative 1 for that. And then here it would be positive 1 for your tangent. So negative 10 to positive 10. Hopefully that made some sense to you. Hopefully you can work through these. I'm going to do another little video with a couple extra problems. One of them for one of the challenge problems on going from rectangular coordinates to polar coordinates. And another one for a little help for the bonus problem. So hopefully you give that a shot. Yeah, let me know if you're struggling with any of this. Send me an email, go to office hours, that sort of thing. And hopefully this week is better than last week. Okay, thanks for being awesome.